Hello there, we're going to look at two tests that we've seen before today. We're going to look at what's called the Wilcoxon Signed Rank Test. Now we actually did this for the statistics in exercise 4B. This then was exercise 4B. And the second thing we're going to do is what's called the sign test, the simple sign test, which was exercise 4A. Now, interestingly, they both broadly do the same thing. They look to see whether or not a sample of a set of data you have has the median you expect. So you might think on average the numbers should be 48, and you're checking to see whether or not it is 48. Could be you think they're above, it could be you think they're over or under or whatever. So, but they both do the same thing, and we've done them both before. So I would very much recommend, if you haven't seen those videos, you go back and have another look. But today we're going to do those both again, but slightly differently. Now, what we're doing here is when we get two sets of data, and we're comparing the two sets of data to see whether the two sets of data are equivalent sets of data. So it might be, for instance, we have a bunch of people that we give a test to. It might be a test about some, I don't know, perhaps they're learning the Chinese language or something like this, and they don't know much about Chinese at the start, and we give them a test and they get a score. And then the important critical thing is we give the same set of people the same test, but maybe a bit later. And you can think of this as a before and after scenario. It would not necessarily always like that, but the basic idea being you get the same people doing the same test before and after to see whether or not it's the same result. This is what we call matched pairs data, and basically the people in this are the same people as that, not like independent groups. And there are some mathematical tests, so you might be, for instance, wanting to test men versus women. And because you've got different groups of people, you might be looking to see whether men perform better on the test than women perform better on the test. They don't look very much like women, but you get the idea of what I'm trying to say. Okay then, so let's go ahead. Now, I did say we've done these two tests before, so I'm going to quickly go through the two tests that we've done before. The single sample sign test, which is the easy one. You just check to see whether the number is bigger than smaller or some number, but they think the median should be 45. So if that's true, this one's definitely above 45. This one's above 45. In fact, that one's not. That one's not. So notice the plus or minus notation. This one's above, 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 above. So my hypothesis would be H0 is median equals 45. And my alternative hypothesis would be that the median, it says, doesn't give a direction, it says different. So not equal to 45. And it's at the 5% level for significance, so 5%. Now, if this is true, then X is binomial. How many have we got here? We've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 9 people there. And the chance of success should be a half if its median is right. And what have we got? We've got 7 above, I think that is, and 2 below. 7 are pluses, 2 are negative. And you should recall that we basically did the probability that X is less than or equal to 2. And we do that with a binomial distribution. Now, if I just do it with my calculator, I think it's already in. No, not quite in. So I'll do it now. Binomial CDF less than or equal to 2. We should recall we always do the smaller of them. Yes, that's right. So 9 is n, p is a half, the x value is 2, and if I do that, I get 0.0894. No, 898, sorry, which is definitely bigger than the significance level of 5%. And so because it's bigger, I do not reject H0. That's essentially the sign test. It's a binomial hypothesis test in disguise, and I can put a bit of wordy stuff with it. Now, the second thing I need to do then is, if you look at this, it talks about use the single sample Wilcoxon Signed Rank Test on the same data. So this is basically it tries to achieve the same thing. I won't write these out again, but we've got the same hypotheses, and we've got a table that we were filling in last time. So those my numbers are going to cross, and now I don't just care about whether it's plus or minus, I care about how much above 45. And that sounds like 17 above. That's 1 above. That sounds like 26 above. 42 is 3 under, that's 5 under. 60 is 15 over, and really I should be putting pluses on these, so I'll put those on now. 52 is plus 7, 61 is plus 16, and 49 is plus 4. So now I ignore the signs, and then I rank the signs. So that's number 1, that's 2, 3, 4, 5, 6, 7, 8, 9, and I finish off by putting signs back on. So this is plus 8, sorry. This is plus 1. And 9 gives me, that's plus 9, minus 2, minus 4, plus 6, plus 5, plus 7, plus 3. So what's that gives me? It gives me 6 of the minuses. So I'm going to write here W minus equal, W plus equals and W minus. And I've just worked out W minus is 6, 9, 18, 24, 29, 39, I reckon. Now the trick, if you recall, is you can do this a half of n, which was 9, times by 1 more than it. And 90 halved is 45. And the critical thing is if you add these up, I get 45. So that tells me it's right. So anyway, my t value I then have to check against. My t value is 6, and I check it against the critical value. Now what is this? This is a 5% test, and it's 2 tail. So looking at my 5% test, 2 tail is there. And my n value was 9, so I think my critical value is 5. So I would write critical value is 5, and 6 is greater than 5, do not reject H0. Now interestingly, they've both given the same result. Okay, so I suppose they're saying the same thing, which is a good sign. And that, I think I've got the same answers there. Okay, so match pairs sign test then. This is the before and after scenario I was talking about before. You get the same scenario in terms of the median of the differences. So we set up this difference between the two scores, and it might be you think that there should be a difference of 0, or it could be you think the difference should be 10. You can do this in a variety of different ways. So this first question, or at least scenario here, is saying the median of the differences is 10. You might think, for instance, that you're not going to pay a company for doing this training unless they can produce a difference of more than 10. So that's what we're testing for. We're going to do binomial again, and then we'll have a look at it to see whether it's true. So let's have a go at this. A heart rate of a group of 6 patients before and after taking the tablet was measured. The results in beats per minute are shown in the table. So the first thing I'm going to do is I'm going to work out the difference. So the difference between them, all I need to know is it positive or negative? I should, I suppose, even before that, write H0. Assume that the shapes of the addition use a paired sign test. So this is it. So I'm going to write D equals, it says use a paired sign test to test whether or not they before and after they've taken their tablet is more than 10 apart. So the difference we're assuming is 10, and H1 it says more than 10. So let's see if we end up with getting this. So let's work out the differences. Is it more than 10? That's what we want. So we're going to work out the differences. So 64 take away 48. You can see that's 16, so that's a yes, if you like. That's a yes. The 90, that's a 4, so that's a no. That's an 11, so that's a yes. That's a negative, it's gone down, so that's definitely a no. This is a 12, so that's a yes. And this is a 13, so that's a yes. So of these, the differences, x is that, it's binomial. How many did we have? We had 6. Should have had half above, half below if it was, the 10 was the right number. But what did we get? We actually got 4 yeses and 2 nos. So if it was me, I'd now write the probability, pick the smaller number, less than or equal to 2. Let's do it on my calculator, binomial CDF again. Turn the calculator on, always helps. Distribution, binomial CDF. I've got 6 of them, 0.5, and I want 2. And it comes up with 0.34. Massive, 344, which is massively bigger than the 10% they suggested. So therefore I think I'm going to do not reject H0. You have to be below the significance level to reject H0. And then there's the wordy bit. What's it say? And they've got exactly the same as me. And it says, therefore, there is not significant evidence of difference between the mean and heart rate. That's the last bit that you're always meant to do, the wordy bit. So the next thing is we can do the same thing with the Wilcoxon Signed Rank Test. Now, I don't intend to go through all of those details again, but suffice to say that we're still going to work out the difference between them, the two values, and we've still got the same idea of the hypotheses. We're going to find W plus, find W minus, look at T and compare it to the critical value. So I've got a table here that puzzle 1, puzzle 2, basically we've got a bunch of people doing Sudoku puzzles. And it's how long they took on puzzle 1 compared to puzzle 2. And we're going to see whether or not it required a different time required to do the two puzzles. So presumably H0. This time I'm setting the difference equal to 0. And then H1 is the difference is it says different to 0. So okay, difference to 0. And I've got a table, the difference, let's do the differences. So I'm going to do top minus bottom. So the difference is 4, 1, minus 2, minus 4.5. 20, that's 8. 5, minus 6. And H. Now this one he couldn't complete it. He had a maximum of hours. So I'm going to pretend it is 60. And 60 take away 32. That was obviously the worst one. And that's the difference of 28. He did then complete on the next one. Now, if that's true, then the modulus of the differences, ignoring the signs, just write them straight down. And then I rank them. That's obviously the smallest. Be careful on these. You wouldn't want to make a daft mistake. Just, ooh, that was a 6, 7, 8. And now the signed ranks. This is plus 3, plus 1, minus 2, minus 4, plus 7, plus 5, minus 6, and plus 8. Now, if I add up the pluses, this is W plus equals 4, 11, 16, I think I get 24, and W minus 2, 6, 12, and my little check again, a half, it goes up to 8, so half of 8 times 9, half of 8 is 4, and 4 9s are 36, and they do equal 36. That's good. So I now know my T value. It's the smallest of the two, which is 12. My critical value, I think I need to check on the next page. And what is it? I've got 8, 10%, 2 tail. 10%, 2 tail, 8, 5. Critical value is 5. And you can see I'm bigger, so 12 is greater than 5. Do not reject H0. And presumably the proper answers say something similar. Where does it say? No significant, do not reject H0. Good. So look, there's a little bit more on that, but I'll worry about that another time. And I don't know what this is. This comes from the specification. This is actually what it says you're meant to be able to do for A-level further maths. So look, that's exercise 4C. We've now done on 2 occasions the signed test and the Wilcoxon signed rank test, and we've still got a couple more bits to do on this exercise 4D coming up. So thank you very much, and I hope you enjoyed the video.